So hello everyone, in this video I'll be discussing about microservices. What are microservices actually? Let's understand that. So before understanding microservices, we should understand what are monolith applications or what is monolith architecture. A monolithical architecture or a monolithical application is built as a single unit. So generally we build an application for any business. We actually build that application as a single unit, which means that all our logical functions like authentication, the payment gateways, the cart, and the other things are created as a single unit. So this kind of approach is called monolith applications. So in a normal monolithical application has a three-part system. One is a database consisting of many tables, usually in a relational database management system, or it can be a non-relational database just like MongoDB as well. A client-side user interface where user can interact with the UI units, for example buttons, images, and other things. These generally contains HTML pages or JavaScript. So maybe it can be a front end of React as well, and a server-side application which will handle HTTP requests, execute domain-specific logic, retrieve and update data from the database, and populate the HTML views to be sent to the browser. So basically, this is the three parts of a monolithic application, which means we use a database, we use a client-side user interface where user can interact, and we use a server-side architecture in which we write our all business logic, and then that server decides whether to give the resource from the database to the client side or not. And all these are contained in a single unit. So this is actually a monolithic approach of building applications. This is what makes a monolithic architecture monolith. It is a single logical executable. To make any changes to the system, a developer must build and deploy an updated version of the server. So basically, if we want any changes or any new upgrade in our application in monolithic approach or in monolithic architecture, we actually need to build the whole application once again and deploy it to the server once again. So basically, this is the drawback of this. So in anywhere, if you want to make the change, then we have to create a separate copy of that application and then we have to redeploy. So that's why this is a monolithic application. Let's understand with a example as well. So there is a single unit in which, for example, there is a e-learning app, which is a single unit application or monolithic application in which you have a payment service, for example. Then there is a authentication, notification, and your UI. Suppose these are the functionalities in your e-learning application, and all these uh, functionalities are actually tightly coupled, which means they are interdependent. So if you want to make change to payment, the authentication, UI, and notification will also be affected, and you have to create and redeploy the app once again. So this is actually the drawback. So all these are connected actually with each other. So basically, this is the system of a single unit or a monolithic application in which all the parts of a single application is actually tightly coupled or connected with each other. If one part is affected, then the other parts breaks down and doesn't work. We have to redeploy the app and we have to start making that. We cannot use the application without a specific part is removed or not. So we have to make the changes in the code, then we have to actually work on the redeployment of the app. Also, one more problem is in monolithical approaches that we use a single tech stack. So if one person doesn't know that, so he cannot make the changes in that, and many problems are there. So in working in a team, sometimes it makes problem when we have a single unit application or a monolithic application. So what are the basic challenges of monolithic architecture? Monolithic application can evolve into a big ball of mud, a situation where no single developer or group of developers understands the entirety of the application. Means when monolithic applications grow bigger, at that time it is very hard to understand what is happening in the application actually, and to understand all the logic we have to make so much efforts in that. So that's why this is one problem in monolithic applications. Limited reuse is realized across monolithic applications. We cannot reuse it multiple times or reuse the same part of the code in multiple application as well. So the same service, for example, the payment cannot be reused in the other one. We have to actually write the code for that as well. So it is the limited reuse in this. So scaling monolithic application can often be a challenge because we cannot add some parts without actually understanding the logic behind the app, or without actually understanding what the app is actually working. So in what is the working principle of the app, we cannot understand that, then we cannot scale that up, we cannot add that up actually. It's difficult to achieve operational agility in the repeated deployment of monolithic application artifacts. Means if you are building a monolithic application and it is deployed, if you want to make some changes, then you have to redeploy the app for for small part of the change if you want. So if you want a small part to be changed, for example in the payment, then you have to write the code for the payment, but you have to redeploy or restructure the app once again and redeploy that app once again. So basically they are deployed, developed and scaled and as a single unit, not a separate one. By definition, monolithic applications are implemented using a single development stack, for example, Java and .NET, which can limit the availability of the right tool for the job. So it can have some problem like if you want something in Java that is not present there, so you cannot use that. You have to rely on some other ways. That's why it is the problem in this, because we are limited to the tech stack in monolithic applications or monolithic architecture. So that these are the problems actually in monolithic application. Why am I telling you this? Because all these challenges are solved in the microservices. So let's understand what are microservices. So microservices are an architectural and organizational approach to software development, where software is composed of small independent services that communicate over well-defined APIs. These services are owned by small self-contained teams. For example, we were working on the last one, the e-learning. I shown you the example that what is a single unit of a monolithic application. In that we had some units of payments and some units of authentication, for example. So all these units in a monolithic applications are contained in one single unit or one tech stack. But in microservices they are actually deployed in a separate containers. So what is this container term? You can think of this as a separate virtual machine, where we are actually deploying the different services in a different container, and then we are using all these services, for example payment service, for example authentication service, all these services by using their APIs. So we are not restricted to a single unit. If you want to make the changes in payment service, then we can independently make changes in that payment service only, and the rest of the app will not be affected with that. Similarly, this goes for the other services as well, for example authentication and other one. So this is actually the approach of microservices. In that we actually create functionalities in a separate container services, and then we use them by using their APIs. So this is the approach in microservices, which solves many problems which we saw just now in the challenges in monolithic applications. All these are actually solved in microservices. Services are built for business capabilities, and each service performs a single function. So basically we create services for business perspective. Like if you want a payment, then that is a business capability or business approach that we want. So we'll be creating that separate service for only that part of service, like that part of business capability. So for only payment, not for the other things. So then we'll be using that service in the in the main app by using that API. So that's why it is independently running our service, which is payment, or it can be any service according to our business needs or our business capabilities. Each service can be updated, deployed, and scaled to meet demand for specific function of an application. So we can update independently, we can deploy it independently, and we can also update that or scale that application if you want some additional functionality as well. So that's the point in microservices. These are separate services in container applications or containers basically, and then we use them by using their APIs. So that's why it makes sense to use microservices over the monolithic applications if our application is very complex and big, and if it is containing many services, for example. So that's why we should use microservices instead of monolithic application architecture. So we can also understand that within our old example, suppose there is one app or our main app, for example, then we'll be using our payment service in a separate container. Then we'll be creating our authentication service in a separate container. Then there is our notification service. Maybe there will be any UI service we want to create, so that can be in a separate container as well. Then we'll be connecting all these services to our app by using their APIs actually. So all these are connected with the APIs, or we can call them by their APIs. And they're also tech stack independent, so we can use them or we can create them with any stack we want by using pipelines or other methods. So this is actually the microservices I explained to you. I hope you understood something. You got something, and if you have some issues or you have some doubts, so you can comment down. We'll be definitely solving that. So this is it for this video. Thank you for watching. Let's meet in the another one.